Hello friends, welcome back in VMware Cloud Foundation Deep Dive Webinar Series Part 8. Today we'll be talking about VMware Cloud Foundation storage options. Before we start, please don't forget to like, share and subscribe with your friends. And don't forget to press the bell icon for new upcoming exciting videos. And if you have any feedback, please feel free to write us back on nextgencf@gmail.com. So today we are on part 8, that is VMware Cloud Foundation Storage Management. What we are going to cover in today's session, in today's webinar, the primary things are: describe the storage options in VCF, recognize the supported type of storage in each type of VCF domain, could be management domain or workload domain. Recognize the connectivity type of options for the supplementary storage that we refer as secondary storage and kind of additional storage that's provided complement with the primary storage. Explain why vSAN best options for VMware Cloud Foundation storage. Recognize the vSAN design consideration, vSAN dedupe compression, storage policies. Then vSAN fault domain. Then we'll talk about vSAN architecture in a stretch cluster and available other storage options like NFS, FC. How can we connect with the VCF environment? So when we say VCF storage overview, the VMware Cloud Foundation primarily refers to type of storage, the principal storage and the supplementary storage. When we say the principal storage, that's deployed during the creation of management domain or workload domain creation. When I say, like, if we are going to create any management domain cluster on the workload domain cluster, and during the creation of cluster, we are choosing the any kind of storage, we are refer as principal storage, whereas supplement storage is an added after domain is created. Any cluster being created in management domain or workload domain, we want to add any supplement storage in the existing environment, which works as a kind of complement with an external, within already available storage, that we refer as supplement storage. So moving ahead, let's understand the difference. Where what kind of storage could be supplement and what kind of storage could be your principal storage. So when we talk about the principal storage for both kind of domain, like in management domain, a vSAN would always be the principal storage always. And in workload domain, the principal along with vSAN is a first choice of choosing the storage, but along with vSAN, vVols, NFS or FC could be the principal storage. Okay. Whereas when we talk about iSCSI can never be iSCSI FC, we could say the iSCSI block storage can only be as an supplement storage for the management domain or workload domain. It can't be never used as an principal storage. Okay. So when we comes to the principal storage like vSAN type, why we prefer put the vSAN as in management domain kind of principal storage. Reason is being during the cluster creation, all my components will be placed, all my management components will be placed under the vSAN data store, and that need to be created during the build process of vSAN, where vSAN bring us a lot of advantage, lot of benefits as compared to using the additional storage or the external kind of storage, FS, NFS, vVols, where it's a lot of complications, lot of administration efforts, and lots of cost get involved in that. So the preference is to go with vSAN. However, the customers are looking for kind of the alternate options. They wants to go some cheaper options with the storage kind of NFS, they can do it. And if there is mandatory and some compulsion to continue with FC and vVol, so VCF provided the options to connect the vVol or FC or NFS as an secondary storage options. So as I said, in the principal storage in management, it's mandatory. Principal storage will be vSAN only. But in any workload domain cluster, beside vSAN, the principal storage could be vVols, NFS, or FC. When we say the supplement storage, supplement work as a complement with your primary storage. A management domain which is configured as primary data store as vSAN during the creation of management cluster. As on add-on and as on kind of the supplement storage, you can add vVols, you can use NFS, or you can use FC as well. Whereas in workload domain, a supplement storage, again, the primary storage could be my vSAN, vVol, NFS, FC, all, whereas the supplement storage could be again within workload domain, we can configure supplement storage vVol, NFS, or FC. So keep in mind vSAN could not be used as an supplementary storage. Either you have to use as a principal storage or no means is you cannot use as in the supplement storage. But in management domain, as I said, the primary storage could be vSAN only. Principal storage only vSAN. Okay, so important note here is in VxRail environment, vSAN only would be the principal storage, whether that is a management cluster or is a workload domain cluster. Reason is being VxRail is my HCI node. So these HCI, the VxRail is the true hyper-converged infrastructure, provides the true hyper-converged infrastructure. So that's mandatorily come with the vSAN configuration. So that's why where we are building the VCF environment in VxRail setup, vSAN would be primary storage in both the cases, does not matter that is the management domain cluster or the workload domain cluster, whereas the other storage could be used as an supplementary storage when we say the VVol, NFS, FC or iSCSI. Moving forward, the vSAN host consideration, what is the things while we are choosing the vSAN host? CPU resource consideration, socket per host, per core, at least we always prefer to keep the dual core CPU at least. A socket should have at least dual core, that's mandatory requirement, or you can have multi-socket environment. So we have to consider CPU to physical core CPU ratio properly and provide at least 10% CPU overhead. We consider as an for the vSAN functionality. Memory consideration perspective, definitely we should keep the separate memory for the VMs, whereas 32 GB memory is recommended for the fully function of vSAN. However, the more storage you will get, the more compatibility you will get. For dedupe and compression, that will increase the minimum, I would say the minimum load, the extra memory load on the base of number of disk we are using while we are enabling the dedupe and compression feature. Where on the other side, dedupe and compression feature, it's saving could save a lot of storage space by enabling these features. So when we say multiple storage controller provide the higher performance. A single storage controller failure affects the small portion overall storage in the host. So a controller could be RAID 0 and pass-through mode. That is my storage controller. A pass-through mode, the controller presents the attached disks directly to the ESXi host, where RAID 0, each of the disk is configured as a RAID 0 volume before presented to the host. Disk failures requires a complete rebuild of the RAID set we have configured in the RAID 0. So always the recommendations always go with the pass-through mode while you are electing the disk, while you are preparing your host for configuring the vSAN environment. When we say the disk controller benefits, that's what we talk about here, multi-storage controller and the RAID 0 and pass-through and the queue depth. When we say queue depth, follow the recommendation from as per the VMware hardware compatibility list, the combination we are taking for our cache drive or the capacity drive, queue depth play very important role there for the performance of storage. The controller cache, most storage controller cache are battery backed. That could be write cache or read cache. vSAN manages caching to disable the controller cache or set it up to 100% read cache. The advanced feature, you should disable the advanced feature for acceleration when controlling the vSAN, when you are using the vSAN environment. Advanced feature, when we say that's the other advanced features are available inside your controller, inside your disk controller. You don't need to be that. Okay. When we factor the vSAN sizing, in the vSAN sizing, your storage policy play an important role. What kind of storage policy we are going to implement on the available objects inside the vSAN data store? It could be the RAID 1, the supported policies are RAID 1, RAID 5 or RAID 6 and different failure to tolerate method. According to that, your object space will take the place, and yeah, definitely we require some object space reservation just to maintain the failure. Then VM home namespace. When we say the VM home namespace, the VM creates its own directory itself. Okay. See, within provision object, and the maximum object size could be the maximum component that you have created maximum is 255 GB, and that's you have where you have to apply the fault tolerance method along with the failure to tolerate policies on the VM home space. Swap space, we always prefer to be the thin provision. So on the right side, you could see just an example where we are saying the raw capacity we took approximately the 10 TB disk size. Out of 10 TB, vSAN metadata overhead would be around 500 GB. The usable capacity you are getting this, and the recommended slack space. When we say slack space always used for maintain your failure. The recommended usable space you are getting this amount, and the extra RAID 5. When you implement the RAID 5 on the policy, that extra RAID 5 overhead would be this, and the recommended effective capacity with the RAID 5 FTT1 you would be getting this out of the 10 TB of space. So we have to be careful while we are doing the sizing for when we are electing the vSAN ready node in our environment. It matters like parallelly you can use multiple types of policies. According to that, your space availability could be dynamics. But yeah, we could refer is like you can run the vSAN sizer tool under the vSAN sizer tool that is available online freely. You can find out like what kind of RAID policy I'm recommending in my cluster, and after putting the all kind of nodes, how much capacity, how much raw capacity, and how much actual capacity I will be getting. Okay, so just a brief overview like how vSAN looks like. So again, the vSAN, what vSAN do? vSAN aggregate the entire disks in a single group from the different host in the form of disk group, and end of the day that's create a vSAN data store. What it creates it creates a vSAN data store. So vSAN in the VCF environment, we don't need to do any manual task during the vSAN creation. It will configure during the build process of your cluster, whether you are using management cluster or the workload cluster. So yeah, definitely cluster requires the network that is dedicated to vSAN, and we have to align this dedicated network for the best performance for the vSAN, whereas 10 GB is the recommended bandwidth should be available for the NIC we are assigning for the vSAN traffic, and the basic requirement kind of vSAN, VM kernel ports and all that also to be configured in advance. When we say vSAN data store, it is enabled by default during the cluster creation. vSAN create two disk group on each VCF node by default. However, that could be customized during the bring up process. Multiple disk group create together a single vSAN data store. A vSAN data store could be hybrid or flash, all flash. When we say hybrid or all flash, hybrid means is you could see here, this box. This one box is representing one disk group. This other box is representing another disk group, another disk group, another disk group, another disk group. As described in the slide here in the left side, like by default, vSAN data store will create two disk group in any cluster environment that we are leveraging for the VCF management cluster or the workload domain clusters. There's two mode. One is hybrid. One is all flash. When we say hybrid, my cache drive will be SSD always, and the capacity drive will be HDD. When we say all flash, the cache drive would be SSD always, and the capacity drive would be SSD along with this. It means that this is a all flash drive configuration where we are getting the better performance as compared to the hybrid mode. When we say hybrid mode, one disk is SSD, another disk is SSD. So for the participation, bare minimum 3 nodes is required for building up kind of vSAN cluster. However, we can make 2 nodes setup that we can talk another video. We are not going too much details about the nodes here. Just for brief information, the management cluster, when we build management cluster, we will be needing 4 node minimum. And when we are creating the workload domain cluster, we will be needing minimum 3 nodes. Okay, so vSAN setting in the deployment parameter sheet that we're referring for building up the management domain. So here you could see the vSAN settings under the deployment parameter section in your deployment parameter sheet. There is a tab of deployment. Then under the vSAN data store, you could see this is my vSAN data store name and the enabling dedupe and compression. By default, no here, but by the way, you can select it yes as well during the bring up process of management cluster as well. However, you can enable this option later also. So dedupe compression that's depend upon your data type, whatever this, it saves you up to 20 to 30% of storage inside your vSAN data store. While we are creating the cluster in workload domain environment, we can enable during the cluster creation with dedupe and compression. Just check it, then it will be enabled, but later on you cannot disable it. So if later on, like if you don't enable during the bring up process of management cluster or the workload domain cluster, you have a choice of You can enable the dedupe and compression later on, but first of all, that dedupe and compression will be applicable for per disk group level. You have to empty this disk group, then you just enable dedupe and compression. Okay, then bring up the data, then again empty another disk group, then enable the dedupe and compression feature. So this dedupe and compression feature will be enabled separately for each of the disk group. But if you are enabling the entire vSAN data store, you have to enable it for the entire set of disk groups. That's the important thing that you have to keep in mind while you are enabling the dedupe and compression. The next comes upon the vSAN cluster scalability. When we say scalability, could be two type of scalability: scale out and scale up. When we say the scale out, it means that if you are lacking with the storage in your environment, just add one more host that will fulfill the compute along with the storage capacity. When we say scale up, where you see the possibilities of increasing the disks and the disk group into the existing environment, you can scale up. For example, a one disk group, a single disk group supports the kind of support the 7 capacity disk along with this one cache drive. Okay, and like if you have another disk group, one cache and the 7 capacity drive, if you want to increase it, then what you have to do, like for example, either you have to add the disk group, or if in case your existing disk group lacking with the disk, you can increase the capacity disk. In this way you can do scale up of your existing node by increasing the disks in existing disk group, or by increasing the number of disk groups. In that way, your vSAN data store capacity will be increased. That's how there is two-way scale out. Either you have to bring up the new host with the same set of configuration, either you can increase the existing host storage. Okay, so when we say the policy-based management, under the policy-based management, where we could configure the number of storage policies, vSAN policy protect the component kind of NSX, SDDC manager, your VMs, and their VMs data in the data store. That's protect from the failure of your disk component failure, or if you the any kind of hardware environment failure. The storage policy meet the following goals. Then categorize the storage based on desired level of service that you are looking for, kind of the protection from failure, provision the disk for optimal configuration, protect data, the object-based fault tolerant, and storage policies are defined certain set of rules. So when we say the certain set of rules, so here you can neglect this heading. Actually, this is more about talking the VM storage policies. So when we are implementing the VM storage policies, apply to the VM home name. Home name means the VM folder, the virtual machine hard disk, the swap object, the snapshots, the memory content, performance data, or if in case we are using any file system kind of NFS services in vSAN. So these all are the different kind of objects where we can implement the storage policies. Multiple virtual machine storage policies can be created within a single data store, wherever the storage policy can be applied to the different objects altogether. Let us suppose we have one set of VMs where we want to apply different storage policy. We have another set of VMs where we want to apply different set of policy. So that's all feasibility is being provided by the vSAN itself. So when we talk about detail about storage policy, number of failure to tolerate, that's we refer as for the redundancy purpose. The number of failure to tolerate value could be where we refer as FTT. It could be 0, it could be 1, and it could be 2. 0, 1, 2 means is no failure to tolerate, 1 failure to tolerate, 2 failure to tolerate, 3 failure to tolerate, and by default value is 1. Where the data stripping per disk, the data we are writing for per object, the striping value by default, the strip value is 1, where the strip value could be 1 to 12. A failure to tolerance method from performance perspective or capacity perspective, by default, we have the failure to tolerate method RAID 1, RAID 5, and RAID 6. The default is RAID 1. However, later on, we can use the kind of RAID 5 and RAID 6. By default value is FTT1, RAID 1. This is the default storage policy, but we can customize it later. Flash read cache reservation, don't normally, there is no flash read cache reservation. If we want to keep some flash read cache reservation for the host for higher performance in reads, we can increase this value 0 to 100%. Force provisioning, when we say force provisioning, it means that if we case, let's suppose we are following up FTT1 RAID 1 policy, which required bare minimum 3 nodes, but actually we don't have 3 nodes, but still we want to create the object, then we can enable the force provision. Force provision by default, this is not enabled in any storage policy. Object space reservation, by default 0. We want to make some reservation, we can make. IOPS limit, there is no limit being defined. If you want to define any limit for per object, you can define. Disable object checksum, by default is no. If you want to enable it, you can press the yes value. When we compare the different failure to tolerate policy with erasure coding, so just a comparison chart, like if you're taking FTT 0, minimum most required 3, the capacity is 1x. 1x is means the data will be stored one place only, but we are not getting any redundancy. But when we are saying FTT 1, minimum most required is 3 and the total capacity we require double of the number, where minimum host required is 4, sorry, in RAID 5. So what we are comparing here is, like if we are configuring the FTT1, sorry, FTT1 failure to tolerance 1, minimum most required 3, then I require the capacity, the total capacity is double of amount. Like for example, I'm going to write the data 100 GB, then it will be consuming the 200 GB of total space. Okay, while we are configuring the FTT1 beside RAID 1 mirroring with RAID 5, I'll be needing 4 host minimum, and the total capacity overhead will go 1.33x, where I could say 33% less as compared to RAID 1 mirroring. When I say FTT2, with FTT2, I need with RAID 1, we need bare minimum 5 nodes. What it means is 5 nodes is 1, 2, 3, 4, 5. Because it's maintaining 2 FTT2, 2 failure to tolerate data, and data, witness, then the total space consumption will go 3 times. When I say 3 times, if we are writing the 100 GB data, this 100 GB data, one copy will be written here, one copy another data, another, there will be 2 mirror copy of original data, and 2 witness component will get created, where bare minimum host requirement is 5. With FTT2, uh, failure to tolerate FTT2, RAID 5 does not support it. That is supported with RAID 6. Within RAID 6, again we need the 4 node where we can maintain the two failure in parallelly. The data will be written in the way data parity. Not witness this time, parity. So it will consume 1.5% as compared to 300%. I mean, the meaning is here is, if 100 GB disk I am writing in FTT2 RAID 1, it will consume the 300 GB of data. But if I am writing the data FTT2 RAID 6, same amount of 100 GB data, it will consume only 150 GB of data. So FTT3 with RAID 1, it require minimum 7 node, and that's going to copy my data 4 times. It means that if I am writing any data, 100 GB of data, that will consume 400 GB of data, while RAID 5, RAID 6 does not support the FTT3 configuration. Okay, so we have to be very careful while we are planning our storage policy, and where we are getting performance and where we are getting the storage optimization. So my recommendation as per the VMware best practice as well, where we are more concerned about the performance, we should always go with FTT1 with RAID 1 mirrored copy always. Where the performance does not matter too much for me and I want the storage optimization, we can choose RAID 5 and RAID 6. Okay. Okay, moving ahead, the vSAN fault domain. When we say the fault domain, we create the fault domain within a data center environment or across the data center environment. But if we are looking the kind of maintaining the rack level of failure, by default in each vSAN cluster, one host is considered as one fault domain. But if we want to design our cluster in a way, if I want to protect from one rack failure, then one rack will consider as one FD. Let us suppose for in this example, we are taking 4 node, 4 node, 4 node. Total 12 nodes here where we have configured the 3-fold domain. Okay, it means that is out of 12 nodes cluster, how I am going to create it? 4 node in one rack, 4 node in another rack, 4 node in 3 rack. So whenever my data will be written, like for an example, I want to write some data with the FTT1 RAID 1. So it means that required data, witness, that required 3 components should be written. So all these 3 components will be write in a way. One of the component will go in one fault domain, another component will go another fault domain, and the witness go in the another domain. Okay, so the way of writing is dynamic, but my data placement will be happen kind across the fault domain. Okay, so that's how we can protect the, like for an example, if the entire rack will go to failure, my data will still be protected. For detail about the vSAN policy, fault domain, and all details, we have a separate webinar where we talked much about the vSAN. You can go ahead and you can refer that. Then vSAN stretch cluster. When we say the vSAN stretch cluster, the main thing here is don't want to explain much about the vSAN stretch cluster, where my one vSAN cluster is stretched across two nearby availability zone. There is certain requirement and certain policy you need to follow. The only main concern here is the vSAN stretch cluster where you have to configure two policies. One is the PFTT, where we refer as primary failure to tolerate policy, that we refer as PFTT would be FTT1, RAID 1. What it means that PFTT is FTT1 and RAID 1. It means that is whenever I'm writing any data, like for an example, a 10 GB data will be written, it will be written in a mirror copy. One copy this side, one copy this side. It means 10 GB on primary side, 10 GB on another secondary side. Then there is another policy that where we want to protect the data locally, we refer as SFTT, secondary failure to tolerate policy. This SFTT matters for us. The policies which we talked about in previous slides, we can configure locally. Like for example, locally I want to configure again FTT1 RAID 1. Then this 10 GB is going to create the two copies here. It means that this 10 GB will be here as in 10 GB and 10 GB. Then again, if I want to locally replicate 10 GB, 10 GB, it means that if I am writing the 10 GB data over PFTT1, FTT1 RAID 1 and SFTT again FTT1 RAID 1, my data will be written on 4 places. 10, 10 here, 10, 10 here. It will take 4 times. However, this SFTT is matter like locally how you want to write the data. The SFTT means that the how you want to protect data locally within particular site. It could be any from the listed policies in the previous slide. These are the listed policy. However, if you want to protect the data remotely across the site, my PFTT will be always FTT1 RAID 1. My data should be mirror across the site. Then vSAN maintenance mode option, we have ensure accessibility data full migration. While we are putting the vSAN host into maintenance mode, the ensure accessibility means is you want to keep the data for the temporary time in the maintenance mode, but this is the default election. Your data will be safe on another host. However, there could be some warning on some of the component just because of redundancy node goes in maintenance mode. Full data migration, if you permanent want to evacuate the node from the cluster, then use the full data migration. No data migration, if you want to just shut down your vSAN cluster, you want to push host in maintenance mode, then you can choose the no data migration option. Other storage options in VCF that we talked about like previously, NFS storage connectivity should be configured, and the inside the network pool there should be two network pools should be available there, NFS and vMotion network pool. Same way for FCSAN, your existing FC fabric FC connectivity should be created there and vMotion network pool should be there. And for iSCSI SAN again, the iSCSI target details should be available and a vMotion IP pool along with this iSCSI IP pool should be available there. Same way for vVol, if we are using with FC, then only vMotion pool. But if we are using for iSCSI fabric kind of that, we require the separate IP pool should be available there. So what we have covered in this webinar, we have talked about the storage available storage options, whatever the primary, whatever the secondary we refer as the principal, and primary we refer as principal, secondary we refer as supplementary storage. The recognized storage options, Why is the preference option of storage, the connectivity method, designing consideration, dedupe compression, storage policies, FT, stretch cluster, and the alternate storage options in the VCF. That's what about this webinar. But before that, I want to take you some important notes so that you can go ahead and you can do some actual practice also, and preferably you can go with the respective VCF release notes for the kind of detailed study you can find under the VCF release notes. If you want to go in deep and dive section, just browse the VCF release notes. Under the VCF release notes, you will find the VCF administration guide. And administration guide, there is module number 9, where you're talking about managing storage in VMware Cloud Foundation. You will get all the details of about the kind of storage being supported and what kind of fabric we need to create and all. Okay. So let's quick jump into the VMware Cloud Foundation HOL. HOL is again, I'm very much fan of HOL. I'm very much fan of VMware release notes for the VMware Cloud Foundation. So in the HOL category, you can search for VMware Cloud Foundation in the search category of lab. Then further you can search for VMware Cloud Foundation, and this is under this you will be finding the lab kind of VCF on HCI. Okay. Under this, you will find that VCF on HCI. I want to just highlight one thing. There is nothing setting you cannot do through SDDC. You can't do through SDDC manager. Only vSAN related setting you have to do through the traditional way you are doing in the vSAN cluster. Okay. Just want to show you some part of configuration. If you will log in inside the any cluster, and then you can go with the cluster. Under the cluster, there is a tab of configure. Under the configure tab, you will find a vCenter tab there in kind of your vCenter environment you are using. Under the vSAN tab, you can go to services, and inside the service section, you can see which all are the services are running under the vSAN environment for now. There are some mandatory services being enabled by default during the cluster creation, like your vSAN performance services. Okay, and kind of if you want to enable another service like file service, dedupe, compression, encryption, that you can do later as well. It will not be impacting kind of things of your environment, but yes, you have to follow the standard process how to enable the particular feature or how to enable the particular services inside the vSAN environment. So you could see the vSAN services here, support inside, performance services by default enable, file services, it is showing me enabled. Yeah, this is the lab environment, but it is not by default enable. Any iSCSI target service is not by default enable. The data efficiency services, kind of data rest encryption, dedupe compression matter. Like if you have enabled it during the bring up process, you can later in reserve letter space, advanced options and all. So if you'll go under the disk management section, inside the disk management section, you will find the available disk group being setted for each and every host. Okay. So for kind of detail about vSAN, you can look up the another videos where we have just trained the people the across the entire over the vSAN environment. Okay. Here you could see there is 4 hosts. Okay. Each 4 host you could see the disk in use 204, 2424. It means that each host have 2 disk group, and out of these 2 disk group, one one of the disk is being used cassette drive, another use being as an capacity drive. Okay. So is there claim unused disks? It's already there. So I don't want to go too much deeper here. Just want to highlight you like from where you can see all vSAN related settings under the configuration tab, and another tab you will find that there is a fault domain, and under the fault domain section, as I said you like if it's a standard cluster, each host is considered as a fault domain. But if you want to make kind of architecture where you want to enable the rack level failure, you have to create the fault domain and you have to move your host into the rack. Same way, if you are enabling the stretch cluster, you have to create 2 fault domain, one fault domain for primary site, another fault domain for secondary site. There is some options of remote data store where you can configure HCI mesh. You can connect the remote vSAN data store as in kind of supplementary storage within the existing environment. So yeah, you can play around the lab, and you can see the available options, what all the available options inside this lab. You can walk through with the configuration section. You can walk through with the monitoring section. Okay. Under the monitoring, you will get many tab related to vSAN over there. As I said, this is not about to talk too much about the detailed deep dive about vSAN configuration and all. We have the webinar is more focused on the storage options available with the VCF. If you wants to do some hands-on, here you could see the vSAN storage policy based management availability lab, vSAN health and monitoring lab. So you can go ahead and you can just follow up the steps being given so that you would get more detail about the vSAN configuration, and you can go ahead and you can see each and every available tab into the vSAN section. But as I said, for the detail about the vSAN, you can follow us and you can see there is another webinar series for the vSAN. You can look up in that. That's it for this webinar, for today's webinar. Thank you very much for your time. Again, I would request you to like all the videos, comments on the videos, share with your friends who are really interested to learn about VCF, vSAN, VMware, vSphere. Subscribe and don't forget to press the notification bell icon over there. So we are coming up with more exciting videos. Thank you very much for the day. That's it for webinar. Have a good day ahead.